these problems are related to horsepower. Actually, the term horsepower was introduced by James Watt, and by definition, when 550 foot-pound of work, by definition, when 550 foot-pound of work is done in 1 second. Of work is done in 1 second. The power developed is called the power required or developed is called 1 horsepower. So 1 HP is equal to 550 foot-pound per second. To solve the problems related to horsepower, a very simple problem is given here. Suppose a man of 100-pound weight, actually the mass of the man is 100 pound, but in this case term is weight. A man of 100 pound, this is the notation for pound, weight. A man of 100 pound weight takes 5 minutes to climb a tower of 1,000 feet. What is the horsepower of the man? Now, if foot-pound unit, the work done, is equal to foot-pound unit. Here, pound multiplied by foot. 100 into 1,000. Foot-pound. So, power is equal to work by time. P is equal to work done by time. In this case, W by T takes time in 1 second. And now 5 minutes. Okay. So 100 into 1,000 divided by 5 minutes means 5 into 60. Foot-pound per second. So in HP unit the power is, when you determine the power in HP unit, then you have to do this technique. In HP unit, the power of the man is 100, this 100 into 1000 by 5 into 60, this divided by 550. In HP, the power of the man is per HP. Now by on simplification, we will get it about 4 by 11. On simplification. So this is the very simple problem. You have to just multiply foot into pound divided by time, second, and the whole divided by 550 is equal to HP. Now the second problem is rather complicated. Okay. A pump of a fire engine. Second problem. A pump of a fire engine lifts 110 pound of water per second. From a reservoir of 7 feet below ground, from a of 7 feet below ground level. The water hits a wall (25 high) with a speed of 16 foot per second. Find the power of the pump. Find So there is a pump. Suppose this is the pump. this is the reservoir from which it lifts water. It is 7 feet below the ground. So this is ground. The depth of the reservoir is 7 feet. And this pump hits a wall. There is a wall here. And the water from the pump hits the wall at a point which is at a height 25 feet from the ground. It is clear the water has been lifted to a height 25 plus 7. So this is 32 feet. When water is lifted from being lifted actually from this point to this point, the potential energy of the water is increased. So energy is required to increase the potential energy, and also when it hits particular this point, it hits with a velocity 16 foot per second. So this is the velocity of water. That means the potential energy and the kinetic energy, two types of energy is given here. Now we calculate the potential energy, the P of water is equal to, at point number B, A, potential energy of water at point B, or increasing potential energy at point B is equal to mg H actually, but in foot pound unit it is only m into H. G is neglected here. G is not necessary. And the work has been done per second, so the time is equal to 1 second. So power required to impart potential energy is equal to m is equal to 110 LB into increase of height is equal to 32 by 1 second. And kinetic energy, power required to impart kinetic energy. Actually, kinetic energy will half mv square. But we are here measuring this amount of energy in terms of foot pound per second. So, a simple technique must be used here. At first, half m means 110 V is equal to 16 foot per second. Okay. Time is equal to 1 second. Actually, the water heating at this point is equal to only 110 pound. But this factor must be half mv square must be divided by 32. Actually, the value of G in FPS unit is equal to 32 foot per second square. Remember, when kinetic energy half mv square is converted in foot pound per second unit, 32 factor is needed, and we divide the whole amount of energy by 32 for uniformity of the unit system. Foot pound per second. Okay. And one simplification we will get here. This is equal to only 440 foot pound per second. So, the total power needed, or total power required to impart potential energy, kinetic energy, total power required is equal to 110 into 32 plus 440. Remember, all these are expressed in foot pound per second. So total power required in HP unit, total power required in HP unit is equal to this divided by 550. 110 into 32 plus 440 whole divided by 550. When foot pound per second is divided by 550, this becomes HP, like previous problem. On simplification, we will get it is equal to 7.2 HP. So power of the pump there are so many problems regarding this power of the pump. The third problem. It is also problem related to horsepower, but the concept is another concept, not lifting, water lifting pump. For all water lifting pumps, if you find any problem related to water lifting pump, then you have to consider the increase in kinetic energy and also increase in potential energy. And when you will calculate the kinetic energy, half mv square whole divided by 32. This must be remembered. Otherwise, the process will be wrong. But in case of potential energy, only foot and pound should be multiplied. Okay. Now the third problem. On a level road, a horse is pulling a car on a horse is pulling a car with a force of with a force of 50 pound weight. If the horse is walking with uniform velocity 6 miles per hour, if the horse is walking with a uniform velocity of 6 miles per hour, mph. Calculate the horsepower in developing. Actually, I am changing this velocity of 8.8 feet per second. 8.8 feet per second. Calculate the horsepower it is developing. Now we have the relation for power. Power is equal to work done by time. Work is equal to force dot displacement by time is equal to force dot d by t. Displacement by time is equal to velocity, force to velocity. So force is given here and velocity also given here. So power is equal to, in this case, 50 into 8.8 foot pound per second. 8.8 per second. Now when foot pound per second is converted into HP unit, it must be divided by 550. Okay? So power in HP unit. Power in HP unit is equal to 5 or 50 into 8.8 by 550 HP is equal to 0.8 HP. Okay. Number 4, find the horsepower of an engine to find which can project 9,900 pounds of water per minute with a velocity of 80 foot per second. The concept of problem number 2 will be applicable here. In this case, this is easier problem. 9,900 pounds of water per minute. So, water lifted here. Answer. Water lifted is equal to 9,900 lbs per minute by 60 per second. Okay. This is water per second. So the kinetic energy is equal to half mv square is equal to half into mass is equal to 9900 by 60 and velocity is equal to 80 square. Okay. Now, when we want to convert this in HP unit, we have to divide the whole amount of energy by 32. So, in foot pound per second unit, in foot pound per per second unit. The power required is equal to half into 9900 by 60 into 80 square by 32 in foot pound per second unit. You may write here foot pound per second. In HP unit, the power is half 9900 by 550 60 32 88 HP. On simplification, we will get here 30 HP. So remember, for kinetic energy calculation purpose, we have to employ a technique that is nothing but the energy divided by 32. It comes due to conversion of unit only, nothing. As 32 is equal to value of G in FPS. G is equal to 32 foot per second square. Okay, these problems are related to horsepower for class 9 only. This class is meant only for class 9, and you will get different types of problems related to horsepower and try to solve all the problems. If you find any difficulties, then response through internet, and make some remarks. I shall try to rectify myself by solving another set of problems. Thank you.